In today's video, we'll be learning about cation analysis. Cation analysis is a qualitative analysis which is based on the fact that ions react with certain reagents to produce observable products. The solubilities of these salts vary, which can be used to separate them. Let's say we have an ion and then we add a reagent and it will produce product. This product can either be a gas, a precipitate, or even a color change. In cation analysis, we have a set of cations and they are categorized under 6 groups depending on their solubilities. The first group, cations, are precipitated as they are chlorides. The second group, cations, are precipitated as they are sulfides. In the acidic media, the third group, cations, are precipitated as they are hydroxides. And the fourth group, cations, are precipitated as they are sulfides. In basic media, and in the fifth group, we have cations that are precipitated using their carbonates. In the sixth group, we have only one cation, and that is the magnesium 2+ cation. And we use a special reagent called 8-hydroxyquinoline in order to precipitate the magnesium 2+ cation. Let's talk about each group separately. Let's say we have a sample containing all the cations for the cation analysis. And then we have the group 1 cations. For this, let's say we have the sample. Let's say the sample is S, and we add diluted hydrochloric acid. And this will give us 3 precipitates. The first one will be silver chloride. The second one will be lead chloride. And the third one will be mercury 1 chloride. All these 3 precipitates are white in color. There is an important thing we need to know about lead chloride. Lead chloride is soluble in excess diluted hydrochloric acid or even concentrated hydrochloric acid. This is because lead chloride will react with chloride ions to form a complex ion which is soluble in water, right? This is soluble. Because of this, Pb2+ ions will still remain in the media unprecipitated. Now, let's move on to the next group, which is group 2. Here I have taken the supernatant from group 1. Since the medium is acidic already, since we had diluted hydrochloric acid in the first group analysis, the medium is acidic. And here we bubble H2S gas. Here we will get 9 precipitates. There, lead sulfide, mercury 2 sulfide, copper sulfide, and bismuth sulfide. These four are black in color. Next, we have the yellow ones: arsenic sulfide, tin 4 sulfide, and cadmium sulfide. These are yellow in color. Next, we have tin 2 sulfide, which is brown in color. Finally, we have the antimony sulfide, which is orange color. The sulfide ions that are required for this precipitation is supplied by hydrogen sulfide. What happens here is hydrogen sulfide, which is dissolved in water, will undergo partial dissociation according to this equilibrium. As the medium is already acidic, according to Nechatley's principle, the system will try to decrease the amount of H plus ions. As a result, the equilibrium will shift to the left, reducing the amount of sulfide ions. The Ksp value of group 2 ions is very low. Since they are very low, even small concentrations of sulfide ions can precipitate them. But if we consider the fourth group sulfides, they have a considerably higher Ksp value. As a result, they need high concentrations of sulfide in order to get precipitated. As a result, in this stage, the group 4 cations will not get precipitated as they are sulfides. As the Ksp value is very low, they are easily precipitated. Let's move on to group 3. First, we take the supernatant from group 2 and then we heat it until all the H2S gas is removed. After that, we take the sample and then we add concentrated nitric acid. This is done in order to oxidize iron 2 plus to iron 3 plus. This is done because the Ksp value of iron 2 hydroxide is greater than the Ksp value of iron 3 hydroxide. As a result, iron 3 hydroxide will get precipitated, but a larger concentration of iron 2 hydroxide will not get precipitated. In order to avoid this, we add concentrated nitric acid and then we oxidize all the iron 2 ions into iron 3 ions. After this, we add a buffer solution of ammonium chloride and ammonium hydroxide. Since the Ksp value of hydroxides of group 3 is very small, even low concentrations of hydroxide ions can precipitate them easily. Here we get 3 precipitates. The first one is aluminium hydroxide, which is a white gelatinous precipitate. The second one is iron 3 hydroxide, which is a red-brown precipitate. And third, we have chromium 3 hydroxide, which is a green precipitate. These are the three cations that are precipitated as they are hydroxides in group 3. The group 4 cations. For this, we take the supernatant from group 3 as we added ammonium chloride and ammonium hydroxide. This solution is basic. Therefore, we bubble H2S gas here, and then we get 4 precipitates. The first one is nickel sulfide. The second one is cobalt sulfide. The third one is zinc sulfide. The fourth one is manganese sulfide. Nickel sulfide and cobalt sulfide, they are black in color. Zinc sulfide is white in color. And manganese sulfide is pink, or I call it light red. Now let's move on to the next group, which is group 5. Here we take the supernatant from group 4 and then we heat it to remove the H2S gas. We take the solution and we add ammonium chloride and ammonium hydroxide buffer, and then after that it is followed by ammonium carbonate solution. This will give us 3 precipitates. The first one is calcium carbonate. The second one is strontium carbonate. The third one will be barium carbonate. All these compounds are white in color. As a result, we use the flame test in order to identify them, in which calcium 2 plus or the calcium carbonate ion will give us brick red color. The strontium 2 plus or strontium carbonate compound will give us crimson red. Barium 2 plus or the barium carbonate compound will give us apple green color. These are the colors, each of these compounds showing the flame test. On to the last group, which is the 6th group. Here we have only one cation, and that is magnesium 2 plus. And this is the structure of the reagent we use, which is 8-hydroxyquinone, and this will give us a yellow-green precipitate, which is a complex molecule. This is the structure of the compound form. We have magnesium here and 2 molecules of 8-hydroxyquinone.